Hey guys, I'm back. This is Miss Gibbs. Let's finish up this test, I hope. Here we go. So number 8, in which equation does the value of x not equal 2? Alright, unfortunately that means we gotta work them all out and see which one doesn't. Okay, we'll plug 2 in and see which one gives you an incorrect answer. So let's try the correct way first, which would be 2x plus 1 equals 4 times the quantity of 2x plus 1. Alright, so I've got to go through my regimen. Don't call me after midnight. I'll leave this side alone for right now, 2x plus 1. So I can get over here and distribute first. 4 times 2x gives me 8x plus, don't forget to get those arrows popping because you also need to multiply 4 times the 1 over there. Don't forget it. So 8x plus 4 is what I get. Now, don't need to combine any like terms because on each individual side, these are unlike terms. These are unlike terms. Alright, so I'm going to move the little guy. Subtract 2x from both sides. Subtract 2x from both sides. I'm going to do my normal 2 steps in 1 here. Canceling out on this side means I need to cancel out the constants, on the other side. Retro. Means I need to subtract, Miss Gibbs, not add. So I'm going to subtract 4, on this side, and therefore subtract 4 on the left side. So when I do that, I got 0 here. A positive 1 and a negative 4 gives me a negative 3. Should be equal to 8x minus 2x leaves me 3x. Can you talk to this kid? 8x minus 2x, leaves me 6x's. And the 4's here obviously cancel out and make 0. Plus 0. So I have 6x is basically equal to negative 3, or negative 3 equal to 6x. Divide both sides by, who's in the way here? It's the 6, not the negative 3. Divide both sides by 6. And I end up finding out that x actually is equal to, thank you goodness, that's negative 1/2, folks. Negative 1/2, so I don't even have to do a whole lot of work. The equation that does not give me a value of x equaling 2 should be the first one. We could double check another one just in case. Let's plug in 4 times 2. This was the other way I was talking about. Plug in the value that you're checking out here, or you need to disprove, and we'll say it equals negative 5 times 2 plus 5. And we'll just use PEMDAS to solve and see if we get a true equation. 4 times 2 leaves me with 8 minus 13. On this side, that gives us negative 5. Just going ahead and checking, working it independently. Negative 5 times 2 leaves me negative 10 plus 5. And then negative 10 plus 5 leaves me negative 5. This was the other way I was saying you could check it, because I get a true statement, so therefore 2 does work. Check one more. I can look in my head, I can use my mental math and say 9 plus 2 equals 11. Over here, 5 times 2 would be 10 plus 11, so that's not it. And we just worked out B and found out that wasn't it. How about D? 2 times 2 minus 1 is 1, so 1 times 2 would leave me 2 on the left side. And if I plugged in 2 here, I'd get 8. 10 minus 8 would leave me 2 there. That works out, so that means that can't work either. Sometimes you want to just take that couple of extra minutes to check each of the other answer choices just to be sure, especially when that answer comes up right away. It could be a trick, or you could have miscalculated. Not assuming you have, but just to be sure. Okay, let's move on to number 9. I want to change my pen color so that we can just see the differences. So I'm going to go over here negative 2. We need to solve for m. Negative 2 times the quantity of m plus 9 is equal to 16. Okay. Negative 2, get those arrows popping as our little video showed us. And don't forget to multiply 2 times both terms. That's negative 2 times both terms. So we get negative 2m. And then negative 2 times a positive 9 leaves us a negative 18. And that should be equal to 16. Whoops. We'll squeeze a 1 in there and make that a 16. Alright. Subtracting 18. Let's undo that subtraction. Add 18 to both sides first. Add 18 to the right. Cancels out on the left. We got 0. 16 plus 18 equals 20. 34. 34 is equal to that negative 2m that's still left on the left hand side. Divide both sides by negative 2. Divide by negative 2. Please show each step and don't assume you know. Divide negative 2 by negative 2. I end up with a positive m. That's what I want. 34 divided by negative 2. A positive divided by a negative leaves me a negative. Go ahead and write it down. And then 34 divided by 2. If you don't know, please use your calculator to find out that it should be negative 17. Alright? To check it, simply plug that negative 17 back in. Negative 2 times negative 17 plus 9 should be equal to 16. This is a question that we have here. So you can always go back and check. Use your calculator to find that negative 2 times negative 17 is a positive 34. And then negative 2 times positive 9 leaves me negative 18. And we're asking, does that equal the 16 that's already over there waiting? 34 minus 18. Use your calculator to find that it does equal 16. So does 16 equal 16? Why, yes it does. And we are finished there. Changing colors again. Excuse me. Alright. Solving for x. 2 times the quantity. I'll try to write under here. 2 times the quantity x plus 3 plus 3x equals 2x minus 9. Well, don't call me after midnight. Let's get those arrows popping and distribute first. 2x plus 2 times 3 is 6 plus the existing 3x over here equals 2x minus 9. Alright, now don't has been taken care of. Call, combine like terms. We have a 2x and a 3x that look very much alike. No, that's not 6x, that is 5x. Add your coefficients. Then we have 5x plus 6 is equal to 2x minus 9. And so what we need to do here is now it's time to move. Move the variables to one side, move the constants to one side. Move the little guy. I'm going to subtract 2x from both sides. That allows us to keep a positive variable term. We're going to subtract those in a minute. Now this canceled out over here. So that means I need to cancel the constant on the other side. So we're going to cancel those here. So I'm left with 5x minus 2x will leave me with 3x's. And that will be equal to that negative 9 that remains on the right hand side. So if 3x equals negative 9, I should divide both sides by 3, divide by 3, and I will find that x, cancel, equals negative 3. Don't forget those signs. A negative divided by a positive leaves me a negative. 9 divided by 3 is 3. Alright, any questions there? You can pause the video. Oops. Let me pause. Okay, continuing. Solve for x. 5 times the quantity x minus 9. Let's go ahead and distribute first. 5x minus positive 5 and negative 8 gives me negative 40. So we write that as minus 40 equals, distribute 6 times x gives me 6x. 6 times negative 10 gives me a negative 60. Alright, no like terms, so they're all unlike terms on the left, unlike terms on the right. Now it's time to move something. 5x and 6x. We move the little guys, so we're going to subtract 5x's from both sides. Subtract 5x from the right. And then if I cancel out on the left, I'm going to cancel the constants on the right. So we're going to add 60 over here, add 60 over there. Drama river. No big deal, we got it. X's cancel out on the left. 60 minus 40 or negative 40 plus negative 60. We have different signs, so we subtract them. Either way, you'll work it out. And checking yourself with the calculator, you'll end up with a positive 20 is equal to 5x minus 6x leave me 1x. 1 and done. X equals 20. Alright. Changing pen colors. I like this. Let's go green. Alright, look at the first few steps in this equation. We got 1x times, 1/2, goodness, times the quantity x plus 2 equals 5. Then go to step 1. We got 1/2 x plus 1/2 times the quantity of 2 times 2 equals 5. Step 2 says we have 1/2 x plus 1 equals 5. Okay, I've evaluated that. Which property justifies step 2? In other words, how did I go from this step to this step? What changed? Okay, so have this. How did I go from here to here? I don't even need to look at this stuff. Okay, so the 1/2 x and 1/2 x, they're the same. That's not part of my issue. Equals 5 and equals 5 at the end. They're the same. Nothing changed there. So I need to focus my attention. Let's use a highlighter here. I need to focus my attention. Oh, that's not good. I thought it would be transparent. Where's my eraser? Okay, excuse me there. Not quite there. Okay, anyway, moving on. 1/2 times 2 gives me 1. What property justifies that? Well, consider this is like 2 over 1. I've obviously multiplied a number times its reciprocal to equal 1. So I have used the multiplicative inverse property. So my answer is D. Pretty easy, yes? Okay. Let's pause and see if we can finish this. Okay, number 13. The steps Malik used to solve an equation are shown. And I'm going to skip ahead to the question. What do we need to focus on? What property justifies the work steps from step 1 to 2? From here to here. That's all I'm interested in. Not paying attention to that, or that. Let's go. What's the same? Mark it out, because that didn't change anything. Oh. Well, I'm going to skip to the end of what's not part of our choices. 42 minus 4 giving us 38 is simple simplification, just mathematical solving, so that's not a property. But 4 minus 4 equaling 0, which is a positive 4 plus a negative 4. Let's go ahead and write that in there. That's what they are trying to get you to see. That a positive 4 and a negative 4 equaling 0 is our what? Additive inverse property. Great. Number 14 should be very easy. In which step of the following equation was a distributive property? I'm simply looking for those parentheses here, and I use the distributive property to go from given to step 1. 1 and done. Number 15. So let's take a pause and come back in just a moment with the last portion.